Here we go again. Now this one, this is the topic of alternating series. It's going to be alternating because it's going to alternate from positive to a negative. And just to kind of illustrate what you're looking at, notice this piece right here. Okay, that's going to, if I expand this out, if I write it out, it's going to alternate. And these, as soon as I see this component, this -1 to the n, you'll notice that what's happening is the function is going to alternate from positive to negative. So I'm going to, it kind of doesn't matter what this part is at all, pretty much. I'll explain that part in a second. But if I start this off, I get, first term is -1. Second term is I plug in 2, I get 1/2. Next to one I plug in is 3, so it's -1 to the 1/3. Plus the next one would be 1/4 minus blah blah blah. Now as soon as I look at this, there's a couple things that automatically are clear. One is it's alternating. Okay. 2, each value is decreasing. 1/3 is smaller than 1/2, 1/4 is smaller than 1/3, etc., etc. So it's decreasing. So I have, it's alternating, it's decreasing, and if I take this other component here and I take the nth test on it, I get 0. Now on an nth test, that would imply no, we have no conclusion. But in this case, if this nth test shows me a 0 and it's decreasing and it's alternating, then I can conclude that this is convergent by alternating series test. That's all you do. The tip-off is the expansions. Once you expand it out and get it in expanded form, it's beautiful. See, right away, I recognize this. Even though right here, even though it says n+1, because this is -1, it's going to be alternating. So I have the first component. The second thing, I'm going to do this quickly, nth test. Now I need the nth test to equal 0 here. Okay. Nth test normally, if I take the nth test of this puppy right here, I'm going to get 0. Okay. Normally that would conclude that I don't have a conclusion. The only thing nth test can do is verify that in fact it diverges if it doesn't equal 0. But when we're doing an alternating series, I need this to equal 0. And the most important, the easiest feature here is to write it out. If I plug in 1, I get a positive 1 times 1 over 1 factorial. If you don't know what that is, I'll remind you again in a second. That's 1. Plus, now when I'm looking for, this has to decrease. Plus, I'll plug in 2. It gives me a -1. So I'm going to change this to subtract. -1, 1 over 2 factorial. 2 factorial means 2 times 1. So this is subtract 1 over 2 times 1 is 2. Plus, plug in 3, I get 4, which makes this a positive. 1 over 3 factorial. And 3 factorial means 3 times 2 times 1, which is 6. Minus, now I can already conclude this right now. First of all, A, it's alternating. B, I got the nth series, it goes to 0. Or basically, it's not the nth test. Basically saying this function goes to 0. And finally, it's decreasing. I have all 3 components, therefore, converges by alternating series test. Now we can get more complicated. Here we go. You got that one right there. Now, again, I'm looking right here first. Okay, the rest of these n's are not geometric. They're not in the exponent. So I'm looking there. That tells me it's going to alternate from positive to negative. This n over n plus 1 becomes the function. Now notice this time, right away, the nth test shows me it equals 1. Let's see if it alternates. So let's write it out. Negative 1. Negative 1 times 1 over 2 is negative 1/2 plus 1n is 2n is positive, so 2 over 3. Then the next one would be plug in 3, so it's negative 3 over 4. Now a couple issues right away. First of all, notice this is not decreasing. Also note, if you take this term here, the n over n plus 1, and you plug in infinity, you get infinity over infinity. L'Hopital's rule applies. 1 over 1 is 1. That didn't go to a 0. So and this conclusion is, since it's getting larger, we're going to conclude it diverges by, now I can do this by a number of ways. First of all, this I just did here is the nth test, but it's alternating. So I can say diverges by nth test, or I can say by the alternating series test. It doesn't pass, it does not decrease here. And this did not, the nth test did not equal 0 on that other term. All right, here's another one. Alternating. So it's the part 1, I see it's alternating. So now I'm going to write it out. Plug in 1, I get positive 1 over square root of 1, which is 1. Minus. I'm confident it's going to be minus because it's an alternating series. Minus. Plug in the 2, you get negative 1 over square root of 2. Plus, continue the pattern, square root of 3. Minus 1 over square root of, I'm not going to leave it as square root of 4. Okay, the question is am I getting, these are getting bigger, therefore this is decreasing. That's real good. Now that's it's alternating, it's decreasing. Let's check that other term. The other term is this one. Other part that's not the alternating part is this one. And if I look at that and I take the limit as n approaches infinity, I get 0. Now normally nth test that wouldn't be not be conclusive, but here we've got this, we've got the fact it's decreasing, and we've got it alternating. Therefore, by alternating series test, it converges. Try this one on your own real quick. Pause the video and look at that one. Okay, you paused. All right, now I'm going to do when you're done, check your answer with this. I started with the fact I see this is alternating, and I see the additional term is 1 over n squared, the non-alternating part, component to it. Now if I plug in 1, I get positive 1 over 1 minus, the next one's going to be negative, is be 2, which makes this negative 2 is 4, plus, plug in 3, I get positive 1 over 9, and I'm going to go ahead and stop there. I already noticed that it's decreasing. You may want to do a fourth term just to confirm, but it is decreasing. take the limit as n approaches infinity of this puppy, I get 0. Now again, the nth test, that would be inconclusive, but here it's part of an alternating. Limit is 0, decreases, and once more, therefore, by alternating series, this is convergent. And that's it for alternating series. Hopefully you like that one. What we're going to do is the next set will be a mix match, and that's what section 9.5 is, and I'll do 2 sets of questions for you to entertain.